Hey, welcome to Global Game Jam. We're here with two of our Unity evangelists. We had a great weekend so far. We're mid-weekend at Global Game Jam, and we had a Unity 3D and also a Unity 2D workshop. So I'll let our evangelists introduce themselves and talk about what they taught so far this weekend and what's up for the rest of the weekend.
So yeah, I'm Santana, and
I'm Kevin Losada.
and we pretty much did the Unity 2D workshop together. Kevin he was there to talk about more setting up the Unity project, setting up your tile map so that way you can make your own levels. And I sort of went through the physics of making your character move and jump in, a traditional platformer.
Yeah, so as far as this weekend goes, we tried to cover, as many bases as possible for beginner game developers, especially in terms of Unity. We know that Unity is a fantastic engine, and we know that it's very beginner friendly. So we try to cater to those people so they can, get into the world of game development. So, with that in mind, for this 2D workshop, we wanted to make it as beginner friendly as possible. Also, because we don't want to take that much time away from people, so they can take time to work on their own games. We've tried to keep the workshops to about an hour to an hour and a half. So for this 2D workshop, we basically focused on, we actually used a free asset pack from the asset store, because right before this we actually had a workshop relating on, finding free game assets. We mentioned the Unity asset store. We thought it would be a good resource. So for this 2D workshop, what we basically wanted to do was explain kind of the main focus of how Unity works in 2D, explain that at the end of the day it is still a 3D engine, explain a little bit about the camera view in 2D. We covered during our scripting and just in general a little bit about the difference between objects that have a 3D and a 2D version. So we spoke about, for example, Collider versus Collider 2D, rigid body versus rigid body 2D. We exemplified some of that when we showed the students the components. And yeah, like Gene said, this particular workshop was honestly very basic because we wanted to just keep it as straightforward as possible. So it's just a simple one character player character, just kind of exemplifying the movement. We spoke a little bit about tile maps, how they work, kind of the history of tile maps and why they're useful. We taught them a little bit about resizing their tile maps to make sure that they have the right pixel size so things are not looking a little bit off. And we can just give you a little bit of a demo of the final product.
Cool. So I'm going to zoom in a little bit.
Yeah, absolutely. We also spoke a little bit about animation controllers. So for this one, we showed them just pretty much the most basic idle animation. We explained a little bit about how animation controllers work, how to work with animation a little bit in 2D and Unity. And yeah, it's a very basic level. This workshop, we were a little bit tight on time, but also it's the fact that we noticed, throughout the jam, most students were focusing on 3D games, and personally, we both love working in 2D. Especially with Unity because it's such a good engine for it, and so we really wanted to do something that was going to be able to, show, even if it's just getting your feet wet, showing what 2D can do. And so that was the basis of this personal 2D workshop. As far as my own 3D workshop, what we basically focused on was, so this workshop was a little bit longer because it was actually part of a two-part series that we covered over the weekend, and so the first part was basically focusing on the Unity engine in 3D, instantiating objects, exploring the hierarchy, working with the scene, working with the game view. And then what I basically wanted to show in this scene was just a very, very basic kind of a player swarm game. So we have basically 4 objects here. We have the player character. We have these here are actually spawners that are spawning these zombies. The player can attack using just ray casting. Right here, the zombies can actually get a little overwhelming if you don't let them. I would have liked to have gotten into things like line renderers, show them how to visualize their scripts a little bit more, but just by the sake of the time constraint, because we did make all 4 of the scripts from scratch, I thought that it would just be a little bit more convenient to just use simple ray casting. So I guess now I just want to show you guys a little bit about the actual scripts that we used. And this game, like I mentioned, it's basically just focusing on 4 objects. Three main character objects. We have the player character, we have our zombie prefabs, and then we have our spawners. So I guess to cover we can just start covering a little bit of an overview on the attack animation. So I mentioned that it was just a simple raycast. All that we're really doing with the attack, we're giving it a distance, we're giving it a max distance that we want a raycast to go. Start method doesn't need anything in it. So in the update, we're simply using the get key down, key code in space. I did explain, and we did this in both the 2D and the 3D workshop, we did explain the basics of Unity and the input class from the API, how to set up your inputs, axes from the project settings. And I wanted to showcase to the students kind of the different ways of doing things, also while explaining, some of the ways that we're doing here. We're doing a shorthand for the sake of time, but they're obviously not the most ideal way to do these things. So yeah, honestly, it's pretty straightforward raycasting here. We're just making it. I set basically.
You have to increase the font if you can.
Yeah, of course. Is that better?
Yeah, it's better.
Better? Okay, perfect. Yeah, so it's pretty simple raycasting. We're creating our raycast here, right here. And then the only real note that I made for them, it's actually two big notes that I made for them, which is, raycast will normally take the transform position, which will normally come from the bottom of the player's model. So here we added a new vector 3 for a little bit of math, just coming from up from the beginning. Because we're using player controllers for the enemies as well, so we don't have any nav meshes, which means that because we're using player controllers, some of the zombies, for example, would come just a little bit above the ground, meaning they weren't getting hit by the raycast. So to kind of fix that, we just raised the vector 3 a little bit. And then right here, the only real notable thing was I did like to show them the draw ray, just so they can kind of see it from this scene view a little bit, how it goes, because I didn't have time to cover line renders or how to, actually animate an attack using a raycast. But this is a very simple attack that we came up with. As far as the enemy, we basically just had the enemy detect the player character upon instantiation. What I did want to cover here was the concept of, I really wanted to showcase the importance of using the start function correctly. So what I basically did here was I wanted to have two types of zombies. In media you see it all the time. You have zombies that are, for example, runners versus walkers, blah blah blah, or different types of zombies. So in this case, that's what I wanted to showcase, just a runner and a walker zombie. So I've made this little variable which is called runner chance. It gives me a range between 0 and 1, and then should the runner chance be higher than 8, so there's about a 20% chance that we're going to get a runner. We actually have right here some public variables for the walking speed and the run speed. And then we have a private variable for the movement speed. So we just assign the movement speed and the animation hash to the proper speed that we wanted to set it, depending on whether or not it was a runner. And then upon update, we just basically have them transform to look at the player, and then we just have them walk towards the player. I did have also, I edited the animation controller. All of these assets that came here, we actually got from the asset store. Because again, I just wanted to make it as simple as possible to make that accessible for the people. So the zombie assets that I used actually had a much more complicated animation controller than this, but to make it a little bit easier to understand for them, I just made it as simple as can be. I have a walking animation and a running animation, and then I have two booleans determining which animation is going to go, and those are both determined upon using start. I also, in the player character, I did refer to the animation parameters by string comparison. Here I wanted to show them the use of a string to hash when dealing with animation controllers by using the animation hash variable right over here. And then apart from that, I just basically did the death object. I just had them do should the zombie run into the player, just destroy the player. I did emphasize to them, and I feel this is something very important in general when teaching workshops of all kinds, especially with something as wide-ranging as game development. One important thing to remember is that a lot of times you want to have a working product that the students can see and enjoy and be proud of themselves and be more driven to explore more. But in order to get a working product like this one, you sometimes have to do very swift, kind of improper scripts. But I always like to clarify whenever I teach one of these workshops that there are better ways to do it. Here I explain to them, ideally you would want to probably have separate scripts that are going to handle a health system and then a death function, for example, and you can have those scripts interact with each other. So, destroying the player object is really no way to handle a death, But the reason that I'm doing it this way here is just because it gives the players, or rather it gives the students of the workshop a more tangible sense of, okay, I made this and now I understand why it works, even if it's not the proper way.
Yeah, the most important part is the fundamentals and
Yeah.
what the functions actually do and sort of the basics of the library and how people can get started up and running.
Yeah.
Because even with the improper way, you can still make a pretty fun game
Absolutely.
with just these few lines of code.
Yeah, and the thing is, we've also had a lot of people that come to these jams that, are very intimidated by the whole idea. They've never done game development. Some of them have never worked in any game engine. And some of them are just, very early into even programming or designing or whatever aspect of game that they do. They're very young to it. So when it comes to these workshops, we try to keep it, as simple as possible so that it's more accessible. For the spawner, I basically wanted to make the spawner to exemplify how much fun you can really have with prefabs. It's a pretty standard thing, on the update, I just have a spawn timer, which I have an initial timer of a spawn time of how long, the minimum amount of time between each spawn, and then have a random added time that is, called upon when I do, it's actually given to the player, and then when I'm doing right here an update, I just check right here in reset spawn timer, anytime that it's instantiated, I give it a random range, so that, there's anywhere between 1 second currently to 2 seconds, that's what I have it set to in my editor, but the players can set their own, the users can set their own, ranges for however much time they want in between it. And the main purpose of wanting to have the spawner was to kind of exemplify the usefulness of prefabs. I feel like they're kind of a concept that for a lot of beginner developers, it kind of eludes them, the usefulness of them. So in this case, I just wanted to make a very simple spawner that would kind of show just how much fun you can have by, you can overwhelm your player if you want. You can actually reduce it, make the difficulty a little bit easier by having less spawners. As far as the stage layout, honestly, it's a very standard stage. It's just old reliable, plane, and just the 4 cubes for the walls. I did explain to them in the first part of the workshop kind of how to put this together. We talked a little about materials, positions, how the transform components work, and just the components in general. One thing that I will say is honestly a little bit difficult whenever we're designing one of these workshops, and I'm sure Gene can agree, is just knowing how much is just right and how much might overwhelm first-time users, because that's really the last thing we want to do is overwhelm anybody and shy them away from using Unity, which is such a good engine and such an accessible one. That's for the main reason also that we didn't use things like nav meshes for the navigation, and we stuck to player controllers. It was just for the sake of keeping it easy, concise, and just not overwhelm the player.
And another part of it is dealing with issues during the workshop.
Yeah.
And deciding how long it'll take to debug an issue, whether it's worth it or to continue on to the next topic. Because it's always disheartening to teach something and all of a sudden you forget a single line of code and like the countless lines that you have to remember from a library.
Right. Yeah, especially because, when you're making these workshops, even sometimes just having all of your scripts written beforehand, like I've usually done, when you're dealing with something as complicated as game engines, you're always going to forget something, or you might overlook something, you forget to declare a variable somewhere, and everything just goes whack. So we always like to give a little bit of time for debugging, and also because we feel like it's useful for the for the attendees of the workshops to kind of see the debugging process from the eyesight of somebody who's had a little bit more experience with it. You just knowing where to look and knowing some of the debug. Some of the parts of the debug function from the API, from the debug object, and what things to use. And then the last thing that I made here was actually the carriage controller. So what I did was I used the carriage controller that came with this asset, and I basically just stripped it down to the most basic components that I could of it. Originally it had things like different forms of update depending on the camera movement that it had or whatever, but I just tried to break it down to as straightforward as I could. For the players. The reason that I chose to stick to the one that it came with is because it basically just, this character fit the style of gameplay that I wanted perfectly. And so, I feel like it might be a bit much to go through the whole script, but I'll just kind of do a little bit of an overview. I'm just here declaring the animator and the rigid body. I did explain to them a little bit about animation, because I feel like, especially from a programming perspective, it's very good to understand animation controllers, kind of the ins and outs of them a little bit when you're working with Unity. So here I'm just declaring them, I'm assigning them at start. Here I just wanted to give them a little bit of a of a nifty head start on the serialized field tag, which I feel like is very useful for any developer. And then here, these are just kind of the constants that we're going to be using for some of our math. And then right here, this specific Boolean for was grounded is used entirely for the animation controller. And then I did explain that to them as well. So yeah, so the way that I kind of did the animation for this and just handling it was, originally this character did have the ability to jump. That's why the is grounded component was so important. And then I did explain that to them as well. I explained, I got this character from an asset because I wanted them to be able to see that you can take things, from external resources and really make them your own and mold them to whatever it is that you want to do. But I didn't want to edit the animation controller because I said, we might in the future have a need for it, so we're going to leave the animation controller normally. We're just going to use our script to modify how we need to. So basically I just have two collisions right here where I'm just checking that the player is currently touching the floor, which by default he always will be. There's no jumping in our little game. And if he is, I'm just setting the is grounded to true so that the animation controller for our character will always have the landing animation that we want. And then right here, basically, as far as the update goes, I did explain to the players a little bit, well, the attendees a little bit about the Unity input functions and the difference between the axes, where you should always use the axes. A little bit, I explained to them a little bit about how to use, scaling variables for your walk and your movement in general. Depending on the conditions that you want to adjust the speed of, for example, your current vertical and horizontal values, so that you can just kind of use those values right here. For example, the float V and the float H. You can use these values when you're doing your actual transforms. And then right here, I explained to them a little bit about the lerp function. I know that functions can be a little bit intimidating for beginners, especially because the Unity API documentation on it isn't that good. So I basically just tried to, exemplify it the best that I could. I explained that when you're using Visual Studio especially, you can take a perfect little look at just a little sneak peek at the documentation of things if you're ever curious. So that's what we're covering here. And then we're just doing transform and transform. I did cover with the users one thing that I thought was very important as well, which was basically kind of the things to watch out for when you're making character controllers instead of even things like a nav mesh, which is the fact that a lot of times when you're instantiating objects, that you got to pay attention to where they're going to be instantiated in terms of, for example, their rotation. I mentioned that even though here we're not using a projectile, should they ever want to make a projectile, that's one thing to keep in mind. Especially when they're using prefabs, since prefabs will usually store the transform component of the parent relative to not in a global scope, just relative to a local scope. Meaning, the prefab may instantiate right here, and if the parent was facing to the right, that thing is going to fly to the right no matter where the player is facing. So I explained to them a little bit about how they would usually in start want to mess around with their components a little bit in relation to where the player is, so that they really get the behavior that they're looking for. Apart from that, honestly, the rest of what we covered was just kind of general things about the engine. For example, I covered a little bit about choosing. I covered a little bit about choosing the proper editor for them. How you can use Visual Studio, you can use Visual Studio Code, the benefits of each, and just any external questions that the students might have had. I tried my best to cover it. And yeah, that was honestly the big bulk of most of the workshops that we taught. Like I said, we really only had maybe two and a half hours total of time to teach these two workshops. So we really wanted to focus on just getting as much valuable information as the players could, so that they can take away from that and implement it in their own games over the weekend.
Awesome. Can you do
a quick demo? Yeah, absolutely. So let me actually edit this a little bit. Perfect. So there's our first zombie. I explained to them also a little bit about the importance of using destroying components after they're no longer useful, and I think a lot of them actually had a lot of fun because a lot of wacky things happened. We had a couple of instances where some of them mistyped the line and they had their spawner. I wasn't waiting any time in between, So we actually had one spawner that spawned like 30 something zombies at a time, and the computer just crashed. And it was really entertaining because it's some things that will genuinely happen as a part of game development. But we talked a little bit about how one of the most amazing things about game development is that it's one of the few kind of programming and just software development in general that you can have bugs like that and just enjoy them because of how funny they can be or how much you can learn from them, about things to watch out for, which really isn't present as much in other types of development.
Some bugs can even be features as well.
Exactly, yeah. Some bugs can be turned into features, which is a very a unique thing about it. If it wasn't for a bug in Street Fighter 2, we wouldn't have combos nowadays, which is the definition of fighting games. So we tried to cover a little bit of all of that. We're really passionate about the Global Game Jam, and we really want to bring as much information that's valuable to all the attendees as possible.
Awesome. Do you want to? That's great. Yeah, thank you so much for teaching these workshops. And do you want to go over a little bit of your workshop?
Yes. So this workshop's way more simple. It's just
with the 2D workshop, we were actually a little bit tight on time. Which was kind of just because we had some other things that were happening that kind of pushed back the schedule a little bit. So we had to rush back on this one a little bit.
But we'll go over like sort of the main basics. Let me reposition the scene right here so they can get a better look. So essentially, we made our little play area right here using something called a tile map. And a tile map, what it does is it places a grid on the scene where you can start placing tiles. And you can actually categorize the tiles, like this tile map, for example, which we can name, like, for example, ground, since we're using this to sort of shape the ground that we're currently standing on. And what you do is once you set up your tile map, you can go to Window, 2D, and Tile Palette. Right now we have the Props Tile Palette, but pretty much tile palettes are sort of containers that have all the tiles that you're going to be using for specific purposes. The props tile palette has all the things that are meant to be props, like the house, for example, which serve nothing more than like aesthetic purposes. And then you have the ground palette, which has all your terrain. So if you wanted to add on to the level, all you have to do is use the paintbrush, select the specific tile you want, and it's kind of like you're going through MS Paint and you're sort of drawing things out.
Yeah, we wanted to show some of the kind of the most awesome features of tile maps, which is they save you so much time in development because with a single tile map you can make such beautiful levels. They make for very good quick games because they're very good on memory storage.
It's amazing for prototyping. Before tile maps, you had to duplicate a whole mess of blocks. I remember I started learning Unity before the tile maps, and that was just a pain.
Yeah, man. Unity, honestly, it's like every year they just put out another feature.
You have to use third-party stuff to like get stuff like this done.
And every time they implement something new, it just makes you have a much better time as a developer.
And another great thing about tile maps is, in a specific tile map, for example, ground, you can add a box collider to every single tile in that tile map. So you don't even have to individually give a collider to each box. As I'm drawing them in, they're actually getting their own colliders. So if I run this, as you can see, I can already hit these blocks and sort of platform on them. Again, another way you can quickly prototype, like World 1-1 of Super Mario in just a couple of minutes.
Yeah, absolutely. We also kind of explained to them a little bit about how this grid object can have multiple tile map children, which is very useful because, like Gene mentioned, you can give specific tile maps their own colliders. So you might have this ground collider, but then you might have a separate tile map for the props, and you might have, for example, one tile map that's props that you want to have a collider, and then props that you might not want to have a collider.
You can set those up with tiles that can actually harm the player.
Right.
You can actually apply a script to an entire tile map that's mostly based on killing the player.
Yeah.
And one of my favorite things is it's a great way to make secrets as well. You can sort of have a tile map that has no colliders, but have it look like the ground, so players can sort of fall into them and be like, oh, this is a nice little secret area.
Little area.
Yeah. So there's a lot of stuff you can do with them.
Yeah, they're a very powerful tool, and I think it's honestly the fact that Unity supports them so well natively is honestly, I think, is one of the reasons that we like working in 2D so much, is because the tools are there and they're so useful for making have a good time developing in 2D as well.
And as for the movement, we only used one script. just handle all the movement. So like Kevin said, serialized fields, which are made so that way when you go, oh, wait, that's another project. When you go over here, you can actually see your variables here on the inspector and actually initialize values for them instead of initializing them in the code, which is amazing for testing, because instead of having to go into the script each and every single time to update values to get the right speed, the right jump height, you can do this in runtime. So that's another nifty thing about Unity. So we have like start functions and update functions.
The font?
Oh yeah. So,
Yeah, just zoom in.
okay. Because they're with.
Oh, that's it.
Oh, there you go. All right. So we have like start and update function. Start being like every time the object is first instantiated into the game, this is the first thing it runs. And I'm pretty much setting the jumped value to be equal to false. This is sort of a state that determines whether the player is jumped or not. And the update is an infinite loop that is checked every frame. So every frame I'm taking in a player velocity by getting the horizontal input of the player. This returns either a -1, a 0, or a 1 based on what direction you're moving in. So if I'm moving to the left, it's going to return a -1. If I move to the right, a 1. And if I'm not moving at all, I get a 0.
Yeah, the reason also that we like to use Get Access Raw for 2D games is because most popularly 2D games are played on D-pads, not using like scroll wheels or anything like that are traditional for other games. So when you're using, like for example, on something like a PlayStation 4 controller, that you have the R3 buttons, you can actually move those and get a range of motion. But those are not really ideal for when you're playing platformers. So Get Access Raw is playing more with the idea of a D-pad where every direction is going to have a single value of input.
Yes.
More directly.
And once you get that value of -1, 1, or 0, you multiply it by your player speed. So now you have a sort of directional vector. So let's say our player speed is 5 and our value is -1. They're pretty much moving, the player velocity is -5, so it's moving sort of 5 pixels to the left every frame.
Yeah.
So once you do that and you calculate this, you can go over here to fixed update. This is similar to update, but it sort of smooths out the checks for each frame, so that way physics aren't frame dependent, so they don't act differently between 30 frames per second or 60 frames per second. Right here you have a constant physics performance. So usually general rule of thumb is handle your inputs on update, handle your physics on fixed update, which is why we have booleans here to sort of tip off what's going on in the fixed update, and then handling it accordingly. For here, if the player velocity is greater than 0, meaning it's moving to the right, then we're getting the rigid body 2D of the character. This is a component in Unity that handles all the physics. So I go over here. All these are components. So the way you reference them is through get component, and you target a specific component, which we're doing here, rigid body 2D. And we are handling this velocity specifically.
Yeah,
velocity, and then you give it a new vector2 object, and you just have to update the x and y values, which the x value being the player velocity, and the y value staying, sort of the same. This is the general y value that you're constantly having on the player character.
Yeah. This is one of the things that we mentioned earlier, how we were trying to explain the differences, because we did teach a 2D and a 3D workshop, exemplify the difference between some components that will behave differently if you give them a 2D version versus a 3D version.
Yeah.
Yeah.
And this is important as well. This basically flips your character sprite depending on the direction you're moving. So if you're moving to the right, then you're going to have your transform local scale, which sort of handles the rotation of your character. Right here, you're moving, you're facing right, whereas the code right here where you're moving left, it's pretty much the same thing right here on the physics side, but you have a -1 here that's supposed to signal, all right, flip the sprite on the x-axis and have it face left this time.
Yeah, and that's something that we explained because it's kind of one of the things that come with one of the curious things that happens with the fact that we're dealing still with a 3D engine, just in a 2D space, is the fact that we can achieve those rotations by just flipping it on a certain axis. Where if it was a purely 2D engine, we might have to, flip it a little bit differently, whether it be maybe having a second copy of it that's already flipped or whatever else we might want to do. It's just one of the little nifty features of working with 2D in Unity.
Yeah, and of course, once there's no more input, we stop the character dead on.
Completely, yeah.
If you just want your character to slide a little bit, you don't need this, as once you let go and without this code, you'd slowly start to lose velocity until you eventually reach 0.
Right.
But since we wanted a full stop once we stopped moving, and this was implemented. And the jump works very similarly, where we get our input for the jump command, which is set in the editor. You go to edit, project settings. And this is the cool part about handling inputs, is not only can you categorize them by name, but it also has controller support, so we can set if we go to jump, for example, we have the positive button as space, but we can set an alternative positive button to be joystick button 1 for like the X
Right.
button on a PS4 controller.
Yeah.
And once you plug in that PS4 controller, Unity is automatically detecting that PS4 controller, which is the way I test platformers usually. So we're referencing that jump, and if you just reference it by name, then it'll check for that space button that's set as the positive value, and we're setting our jumped flag to be true. So that way when we come here to fix update, and we realize that jump is true, then we do our, we reference the rigid body 2D component, and this time we leave the X value the same, but we're changing the Y value to the jump height. And then we just set the jump back to false. So that way we know, okay, we're not jumping anymore until the next time we press space.
Yeah.
And that's pretty much our code here for the 2D workshop.
Yeah, it's very simple, but we kind of focused on providing them a good overview of the main things that they're gonna need to work in 2D and Unity. 2D isn't as difficult. I don't want to say as difficult, but it isn't as expansive as working in 3D sometimes. Just because it does get rid of a entire dimension of things to consider. But we do feel like it's a very different mentality to have, and that there's a lot of different things to watch out for that you don't need to watch out for in 3D. And that especially comes in with this movement script. It's a very, we've worked on some games together, and we've gone through plenty of different movement scripts on 2D characters, and honestly, this very simple system is the best one that we found. And we did explain to them, in the 3D and the 2D workshop, we explained to all of the attendees that, hey, none of what we're teaching you is the only way to do this. Unity is a fantastic engine.
Just moving left and right has so many different
ways.
You can do it by add force, by
Right.
get component rigid body 2D. It's ridiculous.
Yeah, it's endless possibilities, And at the end of the day, the one that works best for you should be the one that you're comfortable making, that you're comfortable editing. And obviously, there's always a million resources out there for whenever you want to maybe implement a specific component to your movement or change something. You're always able to, it's just about being a little scrappy and just knowing where to look.
Yeah, one good thing about Unity is it has so many great resources.
Yeah.
Especially, I learned all my 2D stuff just from YouTube tutorials, self-taught. And there's a whole bunch of content creators that go through 50-something videos on a playlist of how to make a platformer, how to make an RPG, how to make a first-person shooter.
Yeah.
So pretty much any popular genre that you want to make, you have a template right there online.
Yeah, and all of the stuff that you learn at the end of the day, it all comes from mono behavior, it all comes from Unity's API. So anything that you see in a video, once you kind of understand it from the video, you can take it back to your own projects, implement it in your own way, modify it, use it the same way that you found it, whatever it is that you want to do, it's there for you. So.
All right, great, guys. So how did you get into game development? And just talk about yourself. How do people follow you on Twitter?
So I guess I'll go first. So following me on Twitter, you can just find me at KevinL_21. As far as to how I got into game development, so Gina and I actually got into game development together, I think. It was actually through a program at our university where we basically got together with a team of about 20-something other developers, and we got together and we basically built a 2D platformer. It took a lot. It was very rough. It was very scrappy, but it was a really awesome project. We were really proud of it. Since then, we've worked on some other projects together, including Global Game Jam, where we worked together in the past. And it's funny because we were talking about this as Global Game Jam was coming up. It's like we get really busy in between jams, and it's difficult to sometimes find the time to put into game development and working on projects. But whenever this time comes around, it awakens an urge in you to get back into the world and to spend some time with people and you in the Global Game Jam that are like-minded and just work on really awesome stuff.
So, yeah, like Kevin was saying, I did join Spark Dev for game dev specifically. I always wanted to join a group of like-minded people that wanted to work on a game and sort of get the whole team aspect of it. In terms of learning game development, it kind of started when I was in high school in sophomore year. I remember there was a programming class that was specifically video game programming. It was this little IT magnet class in Braddock. And I fell in love with the class. The teacher was amazing, and I learned how to make a sort of math-based like Space Invaders game, and just figuring out how to program that for the first time. That was the first time I ever touched programming. So getting something as simple as moving a bullet from one end of the screen to the other, it gave me this sense of accomplishment that was unlike anything I've ever done. And I realized at that moment, I was like, I want to keep doing this for the rest of my life. I wanted to program. I wanted to get into game development. That's when I was like, okay, I want to do this. So over the years, I've sort of been teaching myself, programming and sort of different engines. I started on libGDX, which is something I dropped, but it was a Java framework for game development, and eventually I switched over to Unity. And I was sort of on and off learning it because, again, like Kevin said, school and work sometimes gets in the way, and sometimes you end up with like months without working on something. But like he said, every time around this, especially since finding out Global Game Jam existed, this weekend has sort of been like a little holiday for me. I always wait for it every single year. I have been coming here for 4 years now. And it's always great to get with a group of friends and just either work on a game, work on a crazy idea, or play Smash Bros. Together. And here we are teaching a workshop.
Yeah, that was a big development for us both, I think.
Yeah, because
How do people find you?
I had to actually look up my Twitter again. I swear
That's fine. I'll tag it on the video. It's fine.
Okay.
Oh, okay, so
Yeah.
all right, I'll give it to you later.
All right, guys. Yeah. So thanks again for teaching these workshops, and
All right,
say bye to everyone.
Bye, guys. Thank you so
Bye,
much.
guys.